Okay, now let's begin the lesson motion and time. In today's class, we are going to solve the exercise. Okay, exercise means along with concepts, we'll cover that also. Because just if I go on giving you answers, you'll not be able to understand. So we'll first try to understand the meaning and definition of that particular concept. Then we go ahead. It becomes easy for you to understand, right? Okay, now let's go ahead. Now coming to here, uh, classify the following as motion along a straight line, circular motion or oscillatory motion they're asking. First you need to understand here first what is motion, types of motion you must know, right? So that we are going to learn here. First one, motion. What is the motion? Is nothing but it is, okay, see, okay, first one, motion definition we are going to learn. Okay, see, if an object changes its position, say for example this is position A, this is position B, right? If an object changes its position from A to B with respect to time, with respect to time, okay, then we call the object is what? It is in motion, or object is said to be in motion. Time is going, it is changing the position from one position to another position, it is changing, it's okay. So when the position is changed with respect to time, we call this as what? Motion, right? Rest. What is rest? Rest is nothing but if an object does not change the position. Now time is going, right? If an object is kept here and time is going here, this is position A, this is position B, right? It is not changing the position, only time is running. Then we can say this object is at rest. Okay, if the object does not change the position, then it is said to be at rest. Now we are going ahead with next one. Okay, next coming to here, types of motion. Let us learn here types of motion, right? What are those types of motion? One by one if you take here, first one, rectilinear motion, right? Rectilinear motion. Rectilinear motion means what? If an object moves along a straight line, see, if an object is moving along a straight line, then it is said to be rectilinear motion, right? Rectilinear motion. If an object moves without changing its position, say for example, see, if this is the top, okay, top, how it rotates, you know that it does not change the position but it rotates, it moves, then we call this type of motion as what? Rotatory motion. Rotatory motion, right? Yes. Next, third one, rectilinear, rotatory. Next, oscillatory is there, circular is there. Okay, now let us take oscillatory motion. Oscillatory motion means what? If an object moves on either side of its mean position, okay, say for example here this object, it is moving on its either side from its mean position, right? Then we call this type of motion as oscillatory motion. This can also be there, or any object which is vibrating on either side from its mean position, we call that also as what? Oscillatory motion. Next coming to what? Circular motion, right? Circular motion means what? Here if an object revolves around another object from a fixed point at a constant distance, means what? It is moving in circular path about another object, then we call this type of motion as what? Circular motion. If you know all these, easily you can identify here what is the right answer, okay, when you read the question. Now coming to the question here, first one, what does it say here? See, classify the following as motion along a straight line, circular or oscillator motion they're asking, right? Motion of your hands while running. While running, hands will be moving back and forth. Means that type of motion, that is called to and fro motion. We call that is what? Oscillatory motion. Oscillatory means what? It is, you can define it like this also, the repeated to and fro motion of an object from a fixed point. Okay, that is also called for oscillatory motion. So here this is oscillatory motion. Motion of a horse pulling a cart on a straight road. This is rectilinear motion. Okay, straight road. So motion of a child in a merry-go-round. What type of motion is that? That is circular motion, right? So that is circular motion. Next, coming to here, merry-go-round. Motion of a child on a seesaw. What is that? Here, you know that. This is child. Okay, seesaw. What happens? This is oscillatory motion. Okay, that is oscillatory motion. Next, coming to motion of a hammer of an electric bell. See, hammer of an electric bell. If you take this, is also, it will be hitting the gong continuously, moving on either side. So that is what? Oscillatory motion. Next, motion of hammer over. Motion of a train on a straight bridge. Straight bridge, if they have mentioned, it is rectilinear motion, right? Rectilinear motion. Next, coming to what? Which of the following are not correct? The basic unit of time is second, they are saying. The basic unit of time is second, means what? SI unit of time is second, it is correct. Okay, this is correct. Next, coming to every object moves with a constant speed. This is not possible. Okay, it is difficult. Every object will not be moving with constant speed because speed will be varying as the objects will be moving. Say, for example, you only take your own bike, it may be car, bicycle, or you are walking, whatever you take. What happens? Cycle, we need to apply sometimes brakes, sometimes we'll accelerate. Bikes also, cars also, same, right? That speed will not be constant. So we can say that no object will move with constant speed. That is not possible, right? Here only if you take here some of the what are celestial bodies which are moving with constant speed, we can say. Here on the earth, that is not possible, right? Next, you see here, every object moves with constant speed. That is wrong, not correct. Distances between two cities are measured in kilometers. See, it is correct. Distances, if you are asked which city, how many kilometers, it is very simple to say that these many kilometers. We always measure that in kilometers, it is correct. Next, the time period of a given pendulum is constant. This is constant. Why it is constant? Because here simple pendulum, if you take here, distance of this length, means length of the thread what we are taking to tie the bob, that will be fixed. If it is 100 centimeter, this is fixed. If it is 50 centimeter, that is fixed, right? Based on this, time period depends. It's very simple. Even if you don't do any experiment, you can easily understand. Just you see, if you increase the full length of the thread there and tie the bob and just make it move on either side, whether it covers longer distance or not, then it takes more time or not, right? If you make it very much short one, shorter distance it is covering, so it takes less time for one oscillation, right? So that is why it is constant, because of what? It depends on the length of that thread which is used for tying that bob. Okay, that is right. So it is constant. The speed of a train is expressed in a meter per hour. See, this is wrong. This is not correct, because speed of the train is usually measured in kilometer per hour. Okay, commonly, if it is asked in SI unit, we are expressing that in meter per second. Okay, in SI unit, meter per second, or in common kilometer per hour, we can say, right? Next, coming to a simple pendulum takes 32 seconds to complete 20 oscillations. What is the time period of the pendulum? They are asking. Okay. So what to say for that? Here, it's very simple. Okay. Now coming to here, we need to solve this. What a simple pendulum takes 32 seconds to complete 20 oscillations. What they have given, time they have given. Time is 32 seconds. Okay. Time is 32 seconds. 20 oscillations. Number of oscillations, let it be n, so 20. So what is the time period they are asking? Time period is given by, how is that? Time taken divided by number of oscillations, right? Here time taken is how much? It is 32, right, divided by 20. So if you cancel this by 2, what do we get here? This becomes a 16 by 10, because 2 times 260, right? So this becomes very simple to express 1.6 second. For one oscillation, the time required to complete one oscillation is how much? It is 1.6 seconds. Just you see, if this is a simple pendulum, here, right? If it starts from this position, goes to this position, reaches this, and again comes back to this position, right? This is one oscillation. We say just one oscillation, moving from the original position, coming to the original position, right? So total time taken for one oscillation is time period. That is what we have calculated here. There is 1.6 seconds for one oscillation, right? Yes. Next we are going ahead with next thing. What is that? Distance. Okay, this one. The distance between two stations is 240 kilometer. A train takes 4 hours to cover this distance. Calculate the speed of the train, they are asking, right? Yes, now you see the distance between two stations they have given. That is what? Distance covered is given 240 kilometers, right? Next, what it is asked here? A train takes 4 hours to cover this distance. Means time it is given 4 hours. It is given. Next, what they have asked? Distance. Calculate the speed of the train. Very simple. Just yes equal to what they are asking, right? So speed is nothing but that is average speed, that only we are calculating. Total distance covered is what? 240 kilometer, right? Total time taken is how much? 4 hours, right? So what can we do is here, just you cancel this. 4 ones, 4 6, here 0 you write. So how much we are getting? 60 kilometer per hour. This is the train's speed. With that speed it is moving train. Okay, it's very simple. Next, these are very much basic questions. Questions is usually anybody can solve. Okay, next coming to here, the odometer of a car reads what it is saying. The odometer of a car reads 57,321 kilometer, and the clock shows the time 8:30. So you need to calculate this. So how to do this? Now you see, odometer initial reading is what? Initial reading of the odometer is 57,321 kilometer, right? And final reading of the odometer, how much it is given? 57,336. Look at this, 57,336 it is given, right? So what do we need to do here? Distance covered is nothing but final reading minus initial reading, right, of the odometer. So what do we need to do? 57,336 minus 57,321. Okay, calculate this. So 36 minus 21, only this much you calculate. So this remains 5. This is 1. 15 kilometers. Distance is 15 kilometer. It has traveled, right? Next, what it is given? Time it is given. Time is what? Time is here. Time taken is 8:30. It is initial time and 8:50 final time. Okay, so initial time and final time. If you subtract that, 8:50 minus 8:30, right? How many? 20 minutes you are getting, right? 20 minutes time it is. So how much if you calculate this one? Here speed is equal to what they've asked actually, to calculate the speed in kilometer per minute also it is asked, express in kilometer per hour also it is asked. Speed kilometer per minute means what? As it is you take distance covered divided by time. Distance covered is how much it is? 15 kilometer divided by 20, right? So if you cancel this, how much do you get here? 5 threes, here 5 fours, so 3 by 4. 3 by 4 means what? If you change this to decimal form, what do we get? if you change it to decimal form, see, you change it 4 into 25, right? Here into 25, this becomes what? 25 fours 100, right? This becomes 25 3 75. This becomes 0.75 kilometer per minute. Okay, in 1 minute 0.075 kilometer it is traveling. Okay, not even 1 kilometer, it is less, it is 3/4 of the kilometer it is traveling, remember. Okay. Next, you have to change this to kilometer per hour, same speed. How? Here 15 divided by 20 is there, right? 20 it is given after cancellation. This is in minute. So what you have to do is, if it is 20 minutes, if you want to change this, what you have to do? 20 divided by 60 you do. If you change this, what do you get? 0 0 gets cancelled, 2 ones 2 threes. Okay, what you are getting? 1/3 you are getting, right? So you take this here, speed is equal to 15 divided by, in place of 20 you have to write 1/3, because this is hour. If you change this goes to numerator. Okay, for simplification. So this becomes 15 into 3. So how much it is? 45 kilometer per hour. In 1 hour it is traveling 45 kilometer, right? It is very simple. Next, after this, what it is given? Next question. Salma takes 15 minutes from her house to reach her school on a bicycle. If the bicycle has a speed of how much it is? Okay. Okay, Salma takes 15 minutes from her house to reach her school. Okay, let us start writing what is given. Okay, it becomes simple. So, okay, Salma takes 15 minutes from her house to reach her school. Time they have given, right? Time is 15 minutes, it is given, right? 15 minutes from her house to reach her school on a bicycle. If the bicycle has a speed they have given. What is the speed? 2 meter per second. 2 meter per second. Calculate the distance between her house and school. Now means what they are asking, distance covered is how much they are asking. So very simple, speed is equal to distance divided by time. You know that. You change this. What if you want distance? You bring it to the left side. So distance is nothing but speed into time, right? So now whatever is given, you express this. Here speed is given in meter per second. This is given in minutes. So time we express in seconds first. 15 minutes. If you express this in seconds, you have to multiply this by 60. 15 into 60. So 15 6 and 90, right? 900 seconds you are getting total. So time is 900 seconds. So distance is equal to this, you formula you write. Speed is how much it is? 2 meter per second. 2 into how much? This time is 900 seconds. 900 seconds. Okay. If you elaborate, you will write full weight. 2, what is that? Meter per second. I'll write like this. Right? It becomes simple for you. And into time is how much? 900 seconds. This is in numerator, this is in numerator. They get cancelled, right? 9 to the 18. 1800 meter. 1800 meter. 1800 meter. If you want this in kilometer, 1800 divided by 1000. Right? Yes. How much do you get? These 3 zeros, you shift the point. 1.8 kilometer. This is the distance her school from her house, right? Yes. Next, coming to here, Salma takes 15 minutes from her house. Okay, show the shape of the distance time graph for the motion in the following cases they are asking. Okay, a car moving with a constant speed, it is asked. As it is already given in your textbook, it's very simple. Here you can see if you are getting a straight line like this, means at equal intervals of time it is covering equal distances, then this type of graph indicates what? It shows it is moving with a constant speed, right? A car parked on a side road. Okay, here one more graph you can show like this. Here you see, here we are taking distance covered. Okay, here also distance covered, as you know already, it is time taken. This will be 0, right? That is origin. As you know that this is y-axis, this is x-axis. I hope you will be knowing that. Only just I am showing about the graph. So now you see here distance covered, here also time taken. If you show here anything from here like this, here you see time is 0. When time is 0, it is showing some distance. Say for example here 80 kilometers. Okay, initial distance also 80 kilometers. After here 0 time, after 10 minutes, after 20 minutes. Okay, after 20 minutes also it is 80. After 30 minutes, then also it is 80. After 40 minutes, then also it is 80. Means what? It is not covering any distance, so it is parked on side road, remember. So this type of graph it shows. Next, coming to this, which of the following relations? Okay, which of the following relations is correct? They are asking. It's very simple. That is speed is equal to distance by time. Okay, this relation is correct. Next, after this second one, okay, what is given? Okay. Yes, next question. What is asked there? The basic unit of speed. Basic unit means SI unit, that is meter per second. Meter per second is the SI unit or basic unit. Just you can see, right? Next, a car moves with a speed of 40 km per hour for 15 minutes and then with a speed of 60 km per hour for the next 15 minutes. Okay, the total distance covered by the car. So as we already done just now, you can go ahead because similar problems are given there. It's very simple. First you calculate what they have given. Time is given, distance covered, speed is given. Okay, speed is given here and the time is given. So what do we get there? If you calculate that, it means you can get the distance covered. Once if the distance covered is given, here again what is given there? Speed is given. Okay, here also what? Time is given. Again you can get the distance covered. Means what? Distance 1, distance 2. Both if you calculate total distance over total time taken, if you calculate, you will get easily that solution. Just you try it. Okay, because everything if I solve, you will not have your thinking ability from that, so you have to try, it's better. Okay, very simple here. What? Speed is given, time is given, distance covered 1 you will calculate. Next, speed is given, time is given, distance traveled 2 you will get. Okay, so you can take this as d1 and d2. Total you have to calculate, that will only that will be that total distance covered by the car. It's very simple. Okay, just I can say, but you have to try for that. I'm leaving. Suppose the two photographs. Okay, this is given in a textbook picture. What you have to do is, idea is like this. Here very simple, you take the picture here. Taking the picture, which car is moving here, and two pictures are given there, right? Fastest car they are saying in the question. Fastest car means what? This is front of all, means this is fastest car. Next it has come till here, say for example. Okay, now distance from here to here, how do you calculate? Total here 1 centimeter means 1 centimeter means it is equal to 100 meter you need to take. Like that you need to calculate. Here total 1 2 3 4, like that. If you calculate how many meters you will get here, calculation, right? So from here to here, say for example here 100 200 300 400 500 6 700. Okay, if it is 700, here 600 initial. If I'm giving you example, if it is 600 meter, if it is showing in the next picture, till here it has crossed, say for example this may be 800, right? Till 800 it has crossed. So what do you do here? 800 minus 600. Distance covered 200 meter you are getting or not? 200 meter you are getting, because 2 centimeters equal to 200 meter. Like that, if you calculate easily, you will get that. So this is 200 meter. Next distance covered, if you get, okay, uh, time taken, how much it is given there already, 10 seconds. Okay, time is given. Okay, distance covered is given, right? So easily you can calculate the speed of that fastest car. See, distance covered, say for example 200 meter, speed is equal to what, distance covered by time. Distance covered is how much, 200, divided by time taken is this one, 10 seconds. This gets cancelled, so what do we get, 20 meter per second is what, speed of the fastest car. So this is an example I'm giving, just you can write on your own. Okay, with scale you can do it, up to the mark you will get that. Okay, next, 9.15 shows the distance time graph for the motion of two vehicles A and B. Which one of them is moving faster? Here A and B, very simple, distance covered. Look at this. Here, if you consider at the same time, say for example here one fixed time will take here, from here to here, if you draw the line at the same time, distance covered, for this is distance covered. Look at this, distance covered is less here, distance covered is more for this vehicle. Okay, so what do we say is, for this vehicle, vehicle A is moving faster, because distance covered is more for this. At the same time, given time is fixed for both, at that time this is covering more distance, so that we can say that this vehicle A is moving faster than vehicle B. Okay, next, coming to here, which of the following distance time graph shows truck moving with speed which is not constant, right? So what to do for this, not constant speed they are saying here. Here it is showing that a constant speed, because it is moving of equal distances it is covering. Here it is not moving at all. If you come to next one, just you can see here this type of line graph which is curved. Okay, this shows what, the vehicle moving with varying speed, not constant speed. This is what, constant speed. Okay, it is moving with constant speed, this is moving with no, not constant speed. Here there is variable speed, this is constant speed, we can say. So these are the answers for the exercise questions. Okay, and in upcoming classes we'll do in detail. Okay, whatever you have doubts, based on that we'll go in detail. Okay. Now those who are finding difficult to understand the exercise solutions, for them I have taken this one. Okay, and in the class we'll continue again. Okay, in depth, in detail we'll cover the lessons. Okay, if you have any doubts you can ask me, so that we can finish the class now. Otherwise I'll take up that topic for next video, if you are asking me anything to do. Okay, otherwise we'll wind up the class. Okay then.